Hello, friend. I hope you will be fine. So I am telling you how I perform CFD analysis. Uh, this is the CFD file, and this is the file which I have to open. We have to open with this. So these are the steps in CFD simulation. First one is geometry, meshing, setup, solution, measure. So first one is geometry. So I made the geometry in Solver and then import it into this design modeler. So let's check how we can import geometry from Solver to in ANSYS. So this is basically first step of the CFD simulation. So you can see that this geometry I made in Solver and then imported into this CFD design modeler. So you can go to file and then import external geometry. When to click on this and where file is located, so you can pick, for example, in our case, um, this is the sorry, this is the CAD model CFD main observer. So first, we have to convert the SolidWorks file into step file or IGS file. So then this step file or IGS file we can import into the census. So this is the first step uh, to generate a solid body or geometry. And second step is meshing. So this one is the meshing of this computational domain, and I use tetrahedron type of the 3D element, which is tetrahedron, and body sizing is about 50 mm. So after that, we have to assign the name selection, and this one is inlet, and this section is outlet, and this is the wall where we can make a uh, name selection in the name selection. So after that, we have to go in setup. So basically, setup and solution are both in one window. So um, now I'm going into the solution setup. that way to open this window. So this is the computational domain. So first of all, we have to go in the model. Uh, so in the first step, we have to choose the multiphase. So by default, it will be off, uh, and we have to choose this mixture model, and then clicking implicit. Okay. After that, we on the energy equation which allow um, to make the transfer analysis, and then we have to select the viscous model. So I choose viscous model K epsilon, realizable and enhanced voltage map. So we have to select this. Okay. Uh, there are two famous models. One is K epsilon and other is K omega. So both we can use, but in this case, uh, K epsilon model is more better than K omega. And then we also own the species transport. So basically, this model allow the uh, two different phases of the fluids. One is like one is water liquid and other is air. So we have to open this on this species transport. Okay. In the phase one, there are two phases. In the phase one, we choose water liquid, and in phase two, we choose air. Okay. And after that, so remaining all other things remain by default. Okay. So in the multi-phase, there are two phase. One is primary phase and other is secondary phase. So in the primary phase, uh, this is the water liquid. I choose water liquid, and in the secondary phase, I choose air. Okay. So after that, we uh, choose the material, air and water liquid, and then go to the bonding conditions. And in the bonding condition, there are inlet velocities for two different phases. One is phase one. In the phase one, so we have to set zero velocity, but for the phase two airs, because the inlet portion, two different flows like air and water will make. So in the second inlet phase, we have to keep one velocity because the average velocity in the Saudi Arabia is about 1 meter per second according to literature view. So in the multi-phase volume fraction, 1. So at the inlet portion, air and water will be go, and then go to method. We have to choose coupled, least case, cell case, presto, second order differential equation, volume fraction, first order, second order, and last one energy is also the second order upgrade. Okay, after that, we have to go the initialization. Then I initialize my solution and then run calculations. Okay, so if one more thing I want to tell you about is models phase interaction. When you will select phase one and phase two primary and secondary phase, water and air. So in the phase interaction, you can see that phase two and phase one interaction, and these two will be by default, which is showing, and then number as mass transfer mechanism one, because one model of mixture model will go from the inlet portion, then reaction, and then select decrease and continues and make a value of the uh, surface tension 0.072, and interfacial area you can see that this is make it by default, which is showing like this phase 2 and phase 1. Okay, after that we will get the results about it. These are the setups in which for the CFD analysis we have to make, and after that showing to make change, do not say change, do not say change, because I don't want to change anything in the solution. So otherwise it will make problem. So go to result portion. So this is the volume render which I also mentioned in the report. So you can see that in this volume render, there are two different phases. One is air and other is liquid. So you can see that there are some changings of the mixture of the model. So uh, some are green parts and other are yellow parts. So you can see that there is some mixing of the air. So if you see, so if you check the volume fraction one contour, so you can see that this is the contours of volume fraction one, which are also shown in the report. So these are the results which are shown in the panel. So if you can check the value of the velocity, which I also mentioned in the report. So this is the velocity contours, velocity variation according to the story. So the uh, air and water mixture go to inlet and make some circulation in this region and then go out on this. So this is inlet and this is the outlet of it. So I make this at plane one. So I have to make a plane like this and then uh, see the results at this section one, plane one. Okay, so this is all about this simulation of the condensation. So I hope you will understand about the simulation.